consider this series the sum from k equals 1 to infinity of 3 minus 4k squared divided by 7k squared plus 6, all raised to the k. And let's try to determine whether this series converges or diverges. Now we note that the terms in our series are raised to the kth power, right? I have an exponent of k. Now that is a really good indication that we should use the root test to determine whether this series converges or not. So recall that for the root test, we look at the limit as k goes to infinity of the kth root of the absolute value of a sub k, right? Where a sub k is just the kth term in our series. It's just this expression right here. So let's rewrite this limit. The limit as k goes to infinity of the kth root of this expression right here, or the absolute value of that expression. So the 3 minus 4k squared over 7k squared plus 6 raised to the k, and then take the absolute value. Now we're going to have to do some work to simplify this expression to really see what this limit is. The first thing I can do is I can just flip-flop the absolute values with the exponent of k, right? Because all the absolute value does is make sure this expression is positive. So it doesn't matter whether I turn the inside positive and then take the kth power, or take the kth power and then turn that value positive. So I can rewrite this as the limit as k goes to infinity of the kth root of the absolute value of 3 minus 4k squared over 7k squared plus 6 raised to the k. And now it's very easy to see that my kth root is going to cancel out with my kth power. And so this limit just becomes the absolute value of 3 minus 4k squared over 7k squared plus 6. Now when I think about this absolute value, right, I want to think about the sign of the expression inside the absolute value. So my 7k squared plus 6, right, this will always be positive. But now my 3 minus 4k squared, right, since k is just a positive integer starting at 1, right, 1, 2, 3, 4, and so on, when I plug that value, any of those values in for k, 3 minus 4k squared will be negative, right? When k is 1, I'll get 3 minus 4 times 1 squared, so just 3 minus 4, which is negative 1, and so on. So this expression in the numerator will always be negative, so the absolute value will just essentially flip this subtraction. So this will become the limit as k goes to infinity of 4k squared minus 3 over 7k squared plus 6. Right? You can convince yourself that all that we've done here in the numerator is just change the sign of this value so it's always positive. Right? For instance, again, when k is 1, now I get 4 times 1 minus 3, or positive 1. Right? So I'm just changing the sign here to be positive. And now this limit is one that I can easily evaluate. I have a polynomial in the numerator and in the denominator. And both of them have degree 2. Right? They both have k squared. And so this limit is just the ratio of the leading coefficients. So this limit is 4 over 7. And recall, when we're using the root test says find this limit And if this limit is less than 1, which 4 over 7 is less than 1, then the series converges absolutely. So let's write that. Thus, the series 3 minus 4k squared over 7k squared plus 6 raised to the k converges. And we know if it converges absolutely, then we know it converges. So we can just put the absolutely in parentheses, right? So our series converges absolutely, therefore it converges, and this is all by the root test.